In this video, we will discuss about the exponential function. Here I have lot of examples. So from those examples, we will identify which one represent exponential function and which one is not. So to do that, first we need to know the form of an exponential function. So an exponential function f of x would be this form. So if f of x is an exponential function, then it would be a to the power x form, where a would be constant, first condition. So a should be constant and a should be more than 0 and a cannot be 1. So these base a need to satisfy these three conditions. First, a should be constant, second, a should be more than 0, and third condition is a cannot be 1. So now I have like 10 examples. Now identify which one represent an exponential function. So if we consider first one, so here a is 2, so 2 definitely constant and 2 definitely more than 0 and 2 definitely not equals to 1. So this one represent an exponential function. Now for b, what is a here? A is negative 2. So a negative 2 is definitely constant, so it satisfies first condition. How about the second condition? It doesn't satisfy second condition because negative 2 definitely less than 0. So this one is not an exponential function because it failed to satisfy this condition. Okay. Now how about third one? So what is a here? A is 1/2, which is 0.5. So 0.5. So this is 0.5. So 0.5 definitely constant and 0.5 more than 0. So that also satisfy, and 0.5 is not equals to 1. So this is also an exponential function. How about this one? F of x equals to 1 to the power x. So here a is 1, so constant. 1 is more than 0, it also satisfies second condition, but it fails to satisfy the third one because third condition said a cannot be 1. So this is not. How about this one? Square root of 2 to the power x, and we know the square root of 2, its value is approximately 1.41. that means it is more than 0, and it is also constant. Square root of 2 constant and it is not equals to 1. So this one represent an exponential function. How about this one? So for this one, our base a should be constant, but here base, this is called base. Okay, this one is called a is the base and x is called the exponent or power. Here base is x, which is not constant. It should be constant, but here the x is a variable, so it failed to satisfy the first condition. So this is not an exponential function. How about 10 to the power x? G, for g. So here a is 10. 10 is more than 0, definitely it satisfies second condition, and 10 is not equals to 1, it also satisfies third condition. So this one, yes. Now for next one, e to the power x, where the value of e approximately 2.71. So here a is e, that means 2.71, which is a constant and more than 0, and it or not equals to 1. So this is also represent an exponential function. Pi to the power x, where the value of pi is approximately 3.14. So if you compare all of the condition, this is also an exponential function. Now for last one, here the base is x, power is also x, but according to this one, base should be constant, but here base is the variable. So this is not an exponential function. Okay. The exponential function are two types. First one is is exponential growth function. So exponential growth function, and another one is exponential decay function. Exponential growth function, first one. So in that case, f of x is a to the power x, and a should be, a is constant. Definitely it should be like exponential function, and a should be more than 1. In that case, a should be more than 1. And for example, so first one, so here a is 2, so this is exponential growth function. So f of x is 2 to the power x. Also here, which one? E is also exponential growth function, because a is, here a is square root of 2, which is more than 1. So b, f of x equals to square root of 2 to the power x, and here g also exponential function. So c f of x is 10 to the power x. Similarly, number h also exponential growth function, because a is more than 1. I also exponential growth function. In real life, population growth follows this one, like exponential growth function, and its graph should be something like this. So the graph of an exponential growth function is this type. If this is x-axis, this is y-axis, and its graph should be something like this one. Okay. So here f of x equals to a to the power x, where a is more than 1. So this is exponential growth function. As you go this direction, as you move direction, the value of f of x increases. So this is exponential growth function. And second type is the b. Second type of exponential function is exponential decay function. And it should be this form: f of x equals to a to the power x, where a should be between 0 to 1. So for exponential decay function, f of x is a to the power x, where a should be between 0 to 1. And in real life, like the radioactive substance, it decay exponentially. Radioactive substance is decay exponentially. For example, plutonium, uranium, those radioactive substance decay exponentially. And if we give some example, so example, so if we pick from here, how about this one, C? C, A is 0.5, so definitely this is between 0 to 1. So f of x equals to 1 over 2 to the power x. This is exponential decay function, and we don't have any more. We can also write this one, f of x equals to 2 over 3, because if we divide 2 divided by 3, it is less than 1. So this is also exponential decay function, and its graph would be like this. This is x-axis and this is y-axis, then its graph would be this type. Its graph would be this type. So at If you move this direction, it will, the f of x will decrease. So f of x equals to a to the power x, where a is between 0 to 1. Okay. And this point is 0, 1. Why? Because when x is 0, then y is 1, because a to the power 0 is 1. So at this point is 0, 1.